Ladies and gentlemen, one of the main concerns about electric vehicles is about charging time. While fueling a combustion engine car takes around 2 minutes, charging an electric vehicle battery takes much longer. Why is it so? In this lecture, we will talk about basics of electric vehicle charging process, look at the basic equations, and get an introduction to smart charging. Let us first start with the charging process. In this image, we can see the battery charging current, battery voltage, and energy stored in the battery as a function of time when a battery is charged. As seen in the image, when the charging of a battery starts, it typically charges at a constant current equal to or less than the nominal current of the battery. During this period, the voltage of the battery increases as the battery gets charged. This is referred to a constant current or CC charging region. Fast charging is done in this CC region. When charging a battery, there is a maximum charging current and charging voltage for safe operation of the battery and to ensure a long lifetime. When the voltage reaches the maximum set point, usually at a state of charge of roughly 80%, the electric vehicle charger changes to the constant voltage region or CV region, where the voltage is maintained while the current is gradually reduced to zero. Charging in this region typically takes a long time as the charging current reduces. Charging is stopped once the current is close to zero. Let us now look at a few general equations for charging. First, the charging power, P charge, is the product of the charging current and the battery voltage, V bat. A battery is hence charged by controlling the charging current. Therefore, faster charging can be achieved by increasing the charging current. Typical units used for electric vehicle charging power are kilowatts, volts for voltage, and amperes for current. Next, the energy delivered to the battery during the charging, E charge, can be estimated as the time integral of the charging power, P charge. The typical units used for charging time, charging power, and energies are hours, kilowatts, and kilowatt hours respectively. If the charging power is a constant, this simply boils to the product of the charging power, P charge, and the charging time, T charge. For example, a 10 kilowatt charger used for 2 hours delivers 20 kilowatt hours. The next important parameter is the charge rate, often referred as a C rate. It is the ratio of the charging power to the nominal energy capacity of the battery. As the charging current increases, so does the C rate. The importance of C rate is that as the C rate increases, battery losses and temperature of the battery increases as well. This eventually reduces the lifetime of the battery. Hence, to ensure the long lifetime of the battery, lower C rates are preferred. Now that we have looked at the charging process, let us now see what is smart charging and how it is different from the conventional charging. When we connect an electric vehicle to an EV charger, charging starts as soon as the electric vehicle is plugged in. The charging occurs at a fixed charging power, and the charging occurs till the electric vehicle charging battery is full. This is often referred as an uncontrolled charging or conventional charging. Now, what is the advantage of this? In the case of multiple cars connected at the same time, then all the cars will charge at the same time when they are plugged in. This may lead to a peak leading on the electricity grid. If the peak is too high, then power lines and transformers in distribution network will have to be upgraded. So more cables, more transformers. Further, this kind of charging has no correlation to renewable energy generation or energy prices, as the charging is dependent on the time of connection and always happens at a fixed power. Smart charging can help overcome these disadvantages. For example, if many cars are connected at the same time at a workplace, smart charging can help to plan and spread the charging power over the day. Here in this figure, one car is charged at a time, one after the other and the other sequentially. Alternatively, the cars can be charged at the same time, but with a lower power for each car, such that the charging is spread over the 8 hours of work time. Or the smart charging system can monitor the electricity network and charge more cars when there is less demand on the electricity network. The most important use of smart charging is the ability to allow the charging of electric vehicles from renewable energy sources and the possibility to reduce the cost of charging this way. In this graph, wind generation, solar generation, energy prices, the load on the grid, and electric vehicle charging profile are shown as a function of time. The wind and solar power generation have their maximum at the start and middle of the day, respectively, while the energy prices and load on the grid are reaching its peak at the end of the day. With smart charging, electric vehicles can be controlled to charge from the wind generation in the morning. Then the charging can be increased to charge from both the solar and wind generation in the afternoon. Finally, the charging power can be reduced in the evening when the loading on the grid and the energy prices are high. It means smart charging can allow the sustainable charging of electric vehicles from renewable energy sources and help to reduce the cost of charging. Finally, let us look at how smart charging is implemented. In case of both AC and DC charging, control and communications are established between the electric vehicle and the charging station using protocols like IEC 61851 and ICO 15118. Through this, the charging current can be continuously controlled in time and in magnitude to cater the different smart charging applications. To summarize, the charging process of an electric vehicle battery has two distinct regions, the constant current and constant voltage charging region. Fast charging is typically done in the constant current region. The C rate is a vital charging parameter, as high C rates lead to increase in battery losses and lowering of the battery lifetime. Smart charging facilitates the control of charging power of the electric vehicle. Through this, electric vehicles can be controlled to charge from the sources like wind or solar when energy prices are lower and charge at the time when the loading on the electricity network is low. This way, easing the load on the electric network.